All right, I'm back and I'm on page 252. I'm not going to do the hand thing this time. I'm at the top and it says, here are a couple of practice problems. Pay attention to each. Many of them illustrate novel new things. So things that we have not seen before that we want to get good at. Some of these I'm going to do in a way where you're going to be like, couldn't I just? And the answer is probably you maybe could just in this case, but I'm going to try to teach you this stuff so that going forward, you'll have every advantage possible, right? So the idea here is we want to learn as much as possible, not just get answers to specific questions. So first question, limit as x approaches -2 of f of x. I look at the picture. This seems pretty straightforward. You're right there, so I'm going to say 4. Next question, limit as x approaches 0 of f of x. You can look and see that the limit from the left and the right are going to be equal. So we're going to end up right here. So that's going to be 2. So these are not bad. I hope it kind of continues like that. The limit as x approaches 7 from the left, which makes sense. Asking about the limit as x approaches 7 from the right doesn't make sense because look at the graph. It doesn't exist to the right of 7. So you would never really be asked that. Also, does the limit as x approaches 7 exist? Kind of an open question. So some people say if only the limit from the left could possibly exist, then that is also the limit as x approaches 7. We don't need to get into this. I'm going to say no. The limit as x approaches 7 doesn't exist because you're not allowed to approach from the right. It's actually like, two reasonable people could disagree in that answer. But I'm going to say that it doesn't exist overall, but the limit from the left definitely exists. And what? Keyboard, get out of here. It does exist. And the keyboard popped up on mine. You can't see that. That's why I sound like a weirdo. You get -2. All right. So far, so good. All right. Now they get weird. The limit as x approaches 1 of a different function, f of x plus 3, is not the graph that we have. We have the graph of f of x, or f of t, or f of u, or f of w. We don't actually know what the variable is. We're just assuming that it's x, but it could be anything. So I'm going to do this in a way that you're probably not going to like. The first way I'm going to do it is I'm going to do something called u-substitution, which is one of the most powerful things in all of math, basically. I mean, like definitely Calc 3 down. So what I'm going to do is I'm going to say, let u equal x plus 3. Okay, so not a big deal. And I chose u because it's the thing inside of here. If that had been 5x minus 8, I would have said let u equal 5x minus 8. All right, now what happens in the limit, the original limit, we want x to approach 1. So I'm going to say, as x approaches 1, what does u approach? Well, if x is approaching 1, then u approaches basically 1 plus 3, so 4. So u approaches 4. Okay, well, then I can replace x plus 3 with u, and I can replace the limit as x approaches 1 with the limit as u approaches 4. So I'm actually going to do that and say that this is the limit as u approaches 4 of f of u. All right, now think back to when I was saying we don't actually know what the variable is for this, and even if you read the question again, it just says the graph of f is given. It doesn't say the graph of f of x. Even if it did, that wouldn't matter because that's just like, you choose to name your independent variable x, I choose to name my independent variable t or theta or whatever. It's just two different ways of talking about the exact same thing, so it doesn't matter. So I'm going to say that this is now the graph of f of u. And if u is approaching 4, then I'm going to be right here. And so that is going to give me an answer of 5. So that's u-substitution. You're going to do it like a million times. Like less than a million. A million is so many you can't even conceive of it, but you're going to do it a lot. Now, alternatively, you could have, and I do not really recommend this, but I recommend that you understand it. You could have thought the graph of f of x plus 3 is the graph of f shifted 3 units to the left, right? Which means that you're essentially going to take, so for example, this segment right here, you're going to take that whole segment and move it 3 units to the left. So instead of being at 1, this will be at -2. And instead of that like maximum there being at 4, it'll be at 1. And then here, And then instead of being at 7, you're going to be at 4. I don't know if I recommend you do this on your graph, but this is the graph of f of x plus 3. And if I look at the graph of f of x plus 3 and I find the limit as x approaches 1, I can see that it's 5. You get 5 either way. The u-substitution route is the way you want to go because it's going to work for you longer. It's like a long-term solution rather than a short-term answer one question thing. So I could do the same thing for the next one. I could shift the graph 3 units to the right, but a better thing to do is our u-substitution. So let's do that. I'm going to say u is equal to x minus 3. And then as x approaches 5, so as x approaches 5, u is going to approach, not equal, u approaches, so it's an arrow, 5 minus 3, so 2. So we can change our entire limit into a limit of u at this point, and that's what we wanted to do. So it'll be the limit as u approaches 2 of f of u. And then if we look at our graph, when we're at 2, this is annoying. When we're at 2, it's not like a great value. It's a value we can find, though. So let's do a little extra work here. This line segment, how to denote this? We'll make an arrow like that. That line segment, I know that the function goes through 1, 1, and the slope of that line segment is what? I'm going to go up 4 and over 3. So the slope there is 4/3. So I'm going to write it in point slope form, which is like the only way you should ever really be writing lines. So y minus 1 is 4/3 x minus 1. And then what I'm going to do is I'm going to sub in 2 because I want to know what's happening at 2. That was like the whole idea. I was trying to figure out what's happening at 2. So if I sub in 2, I'll get, so at x equals 2, I'm going to get 1 plus 4/3. 2 minus 1 is 1, so I just get 1 plus 4/3, which is 7/3. So I believe the answer here is 7/3. Let's think of another way to do that. So, I mean, the other way to do that is the exact same thing. It's just like a slightly different way of thinking. So I'm going to change to a different color. I need to know basically everything I needed to know there. So like I'm here at 1, 1, and I know the slope is 4/3. So if I go over 1, I'm going to go up 4/3. So if I go this way by 1, I will go this way by 4/3. And so if I started at y equals 1 and I add 4/3, I end up at 7/3. We get this answer no matter how we choose to do the problem. So that's good, because if you can do it multiple ways and get the same answer, it means you kind of know what you're doing. Kind of. Probably, definitely, but like, who knows? F of 2. Well, what did we just find? We just found the limit basically as x approaches 2. We called it u, but you could actually change the variable then again. So the limit as x approaches 2 of f of x if you wanted to. That's a weird thing to do, so you shouldn't. But you could have. We actually just found that value, right? Like this at 2, we get that value, and that's what we were looking for. So it's actually just 7/3 again. So good for us. We did all the work. All right, let's see the next thing. F of 0. F of 0, I don't know, like, why did I throw f of 0 in there at this point? F of 0, you can see, we actually already found f of 0 at some point. We did the limit as x approaches 0 of f of x, and we got 2, and the function is continuous. If a function is continuous at a point, it means 2 things, 3 things. The limit exists, the function exists, the limit equals the value of the function. So this function is continuous at x equals 0, so we're going to get the same answer we got for the limit. And that's a thing that will happen. You use those definitions like forwards and backwards. Like you're told the function is continuous, you're told the limit, you automatically know the value. You're told the function is continuous, you know the value, you automatically know the limit, whatever the other option is. You're told the limit and the value of the function, you know they're equal, therefore you know it's continuous. You can do any of those options. All right, and then this one, f of 4 minus f of 2 over 4 minus 2. What I want you to do here is not immediately start calculating. I want you to look at the graph and I want you to think. So 4 to 2, 2 to 4, 4 to 2. All right, so we're going from, I'm gonna need an extreme color here. I'm gonna go with red. We're trying to go from this point to this point. And we wanna know essentially the slope. I mean, that's just a difference quotient. It's like f of 4 minus f of 2 over 4 minus 2. Definitely that's slope. Well, do I need to actually calculate that slope to know it, or have I already done that, right? So this question is basically saying what's the slope of this line segment? But we know that. We've actually used it at least twice. It's definitely 4/3. So the answer here is 4/3. And the moral of the story on this problem is don't jump to calculate. Think about it. Because this problem could have been a lot worse. So this answer that we got is exactly the same as maybe f of 3.72 minus f of 2.11 over 3.72 minus 2.11. Would you want to calculate that? Would you want to like plug those into the line, get the values, do your subtractions, divide? You're just going to get 4/3 because any 2 points on that line, because a line has a constant slope, they're always going to give you the same thing. So think before you actually just jump in and start calculating. That's going to like pay dividends so far down the road. You always want to be thinking like, what am I actually looking at? Not like, what can I dive in and start calculating? Like, this is more of a thinking person's type of math, and hopefully you adapt to that and you get used to it. You look at pictures and you think like, what if I drew a picture if you're not given one? Anyway, I hope this is helpful. I'm going to stop here, come back in another video, and do the rest of this page. I think we'll see. I didn't look at the questions yet, but probably. So I'll see you then.